Welcome back, everyone. In this lecture, we're going to discuss edge detection. We're going to specifically talk about the Canny edge detector, which is one of the most popular edge detection algorithms. It was developed in 1986 by John Canny, and it's actually a multi-stage algorithm. So I'm going to quickly show you the actual steps that happen internally with the Canny edge detection, but when we actually implement it, we won't really see that much of it. It's just going to be a simple one-line call of OpenCV. So don't worry too much if you kind of don't understand all these steps, since it's pretty high level just seeing it in text instead of reading the full paper. But if you're really interested in the multi-stage facet of the Canny edge detector, then check out the resource link for the Wikipedia article, which actually explains all these steps, and then also the paper itself. Okay, so I'm just going to briefly just show you and explain the steps that are taken. The first step in Canny edge detection is to apply a Gaussian filter to smooth out the image in order to remove noise. Keep in mind, as we mentioned in the blurring and smoothing lecture, when you're applying edge detection on an image that has a lot of going on in it, maybe has lots of background noise or just a lot of background features and a lot of foreground features, you may end up detecting way too many edges. So most likely you're going to have to apply your own smoothing and own blurring technique first before the one that's built into the Canny edge detection. But just want to mention that. So after you apply the Gaussian filter to smooth out the image, what happens is you find the intensity gradients of the image. Then the next step in the Canny edge detection process is the algorithm will apply non-maximum suppression to get rid of spurious response to edge detection. Then it's going to apply double threshold to determine potential edges. And then it's going to track edge by hysteresis, which is just going to finalize the detection of edges by suppressing all the other edges that are weak and not connected to strong edges. So essentially, it's kind of a filtration process of getting rid of the weaker edges and only finding the really strong ones. Now keep in mind, as I mentioned, for high resolution images where you only want general edges, it's usually a good idea to apply your own custom blur before applying the Canny algorithm. And we're actually going to show that right now when we jump to the Jupyter Notebook. Keep in mind, the Canny algorithm also requires a user to decide on low and high threshold values. In our notebook, we're going to provide an equation for picking a good starting point for threshold values, but often depending on the image, you're probably going to need to manually adjust that low and high threshold just to see what looks good and what edges make sense to you. So it is a bit of a manual process at first in deciding the low and high threshold values, but hopefully the equation we provide gives you a good starting point. Okay. Let's begin exploring all of this in JupyterLab. Okay, so here I am in my Jupyter Notebook, and I went ahead and ran the several imports that we usually do. And then what I'm going to do is I'm going to read in the image. And in this case, the image I'm going to read in is imread, and we're going to work with that puppy dog face, which is sammyface.jpg. And let's go ahead and show that image. In this case, I'm not worrying about performing color correction on this image because I'm only performing edge detection. I don't really care if the blue and red channels happen to be switched. Let's first show you how you can run the Canny edge detector, and then we'll talk about different ways to try to get better results. If you want to just straight up run the Canny edge detector, just say cv2.canny, and then you provide the image you want to run it on, and there's two main parameters. There's threshold 1, and then there's threshold 2. We're going to start off by just setting these both as the middle value of what a pixel can be. So a pixel can be between 0 and 225, so we'll set them both to be the medium value, and we'll see how that works. So if we just show these edges, we can already see right off the bat, it tends to actually get the edge and general outline of the dog. So I can see Sammy's ear here, a little bit of its mouth, but it's also picking up a lot of edges that are probably just noise. So there's two different approaches we can take to this, and we're probably going to have to use a combination of both. One is actually blurring the image to get rid of certain details and just get general edge detection. And the other one is playing around with the threshold values. And you can go ahead and just play around with threshold values right now if you wanted to. So we can make the min and max just 0 and 255 and see how that performs. And you'll probably notice that it also doesn't perform super great, but it tends to actually pick up some stronger edges. So there's a little bit slight differences between these thresholds versus these ones in the middle. But let's go ahead and show you a formula that may help you out for choosing a threshold. In particular, after you've blurred the image, this formula tends to work quite well. So the first thing we're going to do is calculate the median pixel value. So I'm going to say that the median value of my pixel is NP median, and then I'm going to pass in the image, and it looks like my median value is 64. So it's actually not a super bright image, or at least it doesn't have very strong values in any particular color. Then we're going to set a lower bound threshold and the upper bound threshold, essentially threshold 1 and threshold 2. And a really common formula for detecting these thresholds is to actually just do a comparison between the lowest possible versus some sort of percentage of the median value. So you'll often see a formula like this: integer of the max value between 0 and 70% of the median value. So what this is doing is it's saying set the lower threshold to either 0 or 70% of the median value, essentially 30% below the median, whichever is greater. So 0 right now, that's our floor. If this value, 70% times the median value, happens to be a little higher, then we'll go ahead and choose that one, and that sets our lower threshold. And we're going to do something really similar for the upper threshold, except we're going to go in the opposite direction. We're going to set this to be the smaller between the absolute limit of 255 and then 1.3, or 30% above the median value. So the way to read this one is the upper threshold. Set that to either 130% of the median, so 30% above the median, or the max value of 255, whichever is smaller. Because if we go above 255, we no longer want to choose 1.3 times the median value. Something to note here, again, 64, that's a pretty low median value. So we may probably have to even adjust the upper limit a little higher. Okay, so we'll go ahead and run those thresholds and see if that improved anything. In this case, I don't believe it actually does. So I'm going to copy and paste this canny edges command, paste it in here, and then we have threshold, and we're going to set that to lower and upper respectively. You can go ahead and run that. And it actually didn't look like it improved anything. In fact, it's almost performing worse. We can see here that's detecting way too many edges. And something you may want to do then is if you actually take a look at the upper limit, that's going to be 83, which is quite low. So you may want to begin starting adjusting things like expanding the upper threshold limit to go higher and higher. So maybe as you go plus 100, it begins to generalize a little bit more. But really, the thing that's actually going to help you here is blurring the image first. So let's go ahead and blur that image. And you can use any of the blurring techniques that we've learned about already, but I'm just going to use CV2 blur and apply just a kernel to it. So we'll say image, and then the kernel size for the blurring kernel, I will say that's a 5x5. And now I'm going to, again, copy and pasting that edges, but instead of doing it on my image, I'm going to do it on my blurred image. And I will use the upper and lower ones that I calculated earlier. So we'll say lower and then upper. So now when I run this, and I see the edges, now I'm definitely seeing the stronger edges of the dog's face. And in fact, this is probably the best one we've seen so far. If I compare it to the other ones, they're still picking up a lot of noise. So compared to the original image, the one that's really showing the strong edges of the dog's face is this last one after we've been able to blur the image a little further. And if you want, you can then experiment also with the kernel size here, maybe expand it, see if that continues to blur the image until you only see what you're looking for. And what you can also do is then expand maybe the upper limit here to like 50, and let's reduce this kernel size. That's probably a little too blurred. Do a 5x5 there, run this, and you can begin to have some sort of happy medium where you're detecting the edges you want to detect without detecting too much noise around it. So again, we can clearly see here the dog's face. Okay, main things to know here is just call cv2.canny, pass in your image, and then using these formulas, you can play around as good starting points of your lower and upper threshold, but more likely than not, you should blur the image and then also play around with the threshold amount until you see something satisfactory. Thanks, and we'll see you in the next lecture.